Good morning, pre-calc students. I apologize if you tried the video earlier. It was not working. I tried to make a shareable link. It wasn't working. So here's round two. I will run through the video or the lesson again for our chapter 11.2 day 3 notes, and hopefully it'll work this time. So again, I'm going to get rid of a couple of these notes and post a new one, and hopefully it works for you. This is our last set of notes. Of course, we have trouble with that, right? All right, so what this is talking about is limits and motion, the area problem, and it's the last part. So let's think about having a gallon of water. If we have a gallon of water and we divide it equally into teacups, we want to find the amount in each teacup and the total amount of water. Well, if I have 10 teacups and I divide up my gallon, I have 1/10 of a gallon in each cup. I still have 1 gallon of water. If I have 100 teacups, I have 1/100th of a gallon in each cup. I still have 1 gallon of water. If I have 1,000,000 teacups, I have 1/1,000,000th of a gallon in each teacup. I still have 1 gallon of water. But what happens if you have an infinite number of teacups? Well, obviously you cannot pour 1 gallon equally into each of those teacups. So you have 0 in each of those teacups, but you still have 1 gallon of water. Well, how does that work? That's where limits and infinity come in. So while we were able to come up with the total amount for the infinite number of teacups situation, finding the amount in any single teacup wasn't straightforward. This is why mathematicians use limits whenever the concept of infinity is involved. So we're going to look at the limit as x approaches infinity of our function, and it equals L. So again, what does this say? It says that we are going to interpret the meaning that f of x gets extremely close to L as x gets extremely large. Because again, infinity is not a specific number. It's just representing something very, very big. So our x's are approaching something very big, and then our function is going to get very, very close to this L value. Now, the definite integral can be written a couple different ways. So when we take the concept of RAM, so rectangular approximation method, but use an infinite number of rectangles, we come up with the definite integral. So this first one, I is going from 1 to n, of our function f of x dx is a way to show a sum of the area of n rectangles with height, here's our height, f of x, and width dx. So we have these rectangles, n number of rectangles, and we're going to find the area of each one with a height of f of x and a width of dx. If we look at this, we've now added the limit as n approaches infinity. So we're approaching an infinite number of rectangles. So this is a way to show a sum of the area of n rectangles with a height of f of x and a width of dx, with the number of rectangles approaching infinity. Again, the more rectangles you have, the more accurate your area is going to be. This last one, it's the integral from a to b of our function f of x dx. This is the way to show the area under the curve of our function f of x within a specific interval from a to b. So what does that mean to us, and what does this all look like for us? Let's look at our first example. We're going to look at it as an integral. So again, all this is saying is we're going from -2 to 5. So I draw a graph, sketch it out. On my x-axis, I'm going from -2 to 5. And my function is just 6. Well, 6 is a horizontal line. Right here, you can see I drew the horizontal line in black. Well, what am I doing? I'm boxing off from -2 to 5, and then I have this horizontal line. So I've now created this red rectangle, and I'm looking for the area inside this red rectangle, and that's why I shaded it in. So the area of my rectangle is just length times width. Well, the length we can count. From -2 to 5, a length of 7, and our width here, we go up to 6. So the area of this rectangle is 42 units squared. Again, we're looking at the area underneath the curve from this integral from -2 to 5 with our function at 6. We're going to look at another one. This time when we graph, our integral goes from 1 to 5, 1 to 5. And we graph our line or our function 2x. Again, it's a line with a y-intercept at 0 and a slope of 2. If you want to graph on your calculator, that might help. When we box this off from 1 to 5, we go with the x-axis as our base, and then we've got here this other piece. We've now created a trapezoid, and our blue area inside this trapezoid is what we are going to look for. What is the area formula for a trapezoid? 1/2 height times base 1 plus base 2. Here's my height from 1 to 5. How do I get the length of the bases? I plug in 1, and then I plug in 5 into my 2 times x. So again, 1/2 times my height. My height is always along the x-axis. From 1 to 5 is a height of 4. The bases are here in blue. Okay, how do we get the length? 1 times 2 is 2. 1 times 5 is 10. Total area of our trapezoid is 24. Let's look at another trapezoid. Now again, this is my sketch. You do want to sketch this out, but use your calculator if it helps you to draw this line. When I graph my function, x over 3 plus 5, here's my function. Okay, I'm going on the x-axis from -6 to 3. Okay, I'm creating my trapezoid. Here we go. So we have 1/2 times the height. What is the height? From -6 to 3 is 9. What is this showing? This is showing the length of base 1. Base 1 occurs at -6, so we plug it in. -6 divided by 3 plus 5, plus base 2 occurs at 3. 3 divided by 3 plus 5, and we get the area to be 40.5 units squared. Now the last one has a different shape. When you graph this, this is a semicircle. We've seen this before. We have a semicircle. So what is the area of a circle formula? Pi r squared, but it's a semicircle, half a circle. So we plug this in. 1/2 times pi times a radius of 2 squared gives us the area of a semicircle at 2 pi. All right, so I know that was real quick, and I do apologize for those of you in the first hour class that the video didn't work, but I'll post it, and hopefully it works. Here's your book assignment due at our next class meeting on Thursday. Worksheet is not due until our test on Monday. Have a great day, guys. Thanks so much. Can you find